I don't think most people understand just how quickly machine intelligence is advancing. It's much faster than almost anyone realizes, even within Silicon Valley, and certainly outside Silicon Valley, people really have no idea. So
why is that dangerous?
I mean, if there's a super intelligent, particularly if it's engaged in recursive self-improvement, if there's some digital super intelligence and its optimization or utility function is something that's detrimental to humanity, then it will have a very bad effect. It could be just something like getting rid of spam email or something, and it's like concludes, well, the best way to get rid of spam is to get rid of humans.
But why would we lose?
The source of all spam.
I know we've all watched HAL in 2001, but why would we lose control over our machines? There are no data points showing that our connection to machine has ever been loosened.
Actually, I think the thing to do would be to plot the progress of digital intelligence versus time, and then to maybe curve fit or extrapolate that progress and see where that leads.
But you're talking about machines that are not just intelligent, but have intentionality. Is that right?
They have the intention of their utility function,
which is what we programmed in, right?
Yes.
Okay.
But it can have unintended consequences.
So this presentation is being presented by Raju Mohan Reddy, Maribeth, Rahul, Sadashiv, and Bharadwaj. In this presentation, I'll be talking about why within 50 years we cannot expect to see information technologies capable of same type of flexible common sense reasoning that humans alone are capable of today. As you can see in this sci-fi world, in movies like Terminator, where AI has taken control over humans, or in TV shows like Westworld, where humans live in a world where AI provides them with entertainment, we have envisioned that AI is capable of doing a lot in the future. But I would like to make a check on all those assumptions and would like to differ, as AI is not that capable of being able to reason as a human, even in the next 50 years. In this presentation, I would throw some light on what AI is, what its history was, what are its challenges and some of its limitations, where AI has failed, and what are its implications. In simple terms, AI is a branch of computer science that deals with the simulation of intelligent behavior in computers. According to Merriam-Webster dictionary, the capability of a machine to imitate intelligent human behavior is called artificial intelligence. If we just use common sense, artificial intelligence is concerned with the human ability to understand and manipulate information about the everyday world of objects and their interactions. The concept of artificial intelligence first came across in the 1950s when John McCarthy first introduced the term artificial intelligence. Norbert Wiener wrote the famous principle of feedback theory, and during the World War, Alan Turing developed Turing machine and wrote a test which tests the machine's capability to behave as intelligent as human. This test is still served as the benchmark for AI research. 1956 to 1974 were considered the golden years of artificial intelligence. AI winters is considered as a time period where the funds given to research in AI was lessened, and it were from 1974 to 1980 and 1987 to 1993. For the overview of AI, I'll be going through these three main topics: symbolic AI, connectionism, and application of neural networks. So symbolic AI methods in artificial intelligence research that are based on high-level symbolic representation of problem and logic. The domain paradigm of AI research from the mid-1950s until the late 1980s was in this particular thing. The challenge faced by symbolic AI is to translate all the implicit knowledge unavailable to conscious awareness into an explicit form through symbols and rules. In connectionism, a sub-symbolic approach is used. Modeling approach modeling approach to information processing based on the interconnected network architecture of the brain. Most common models that are neural networks are used in these cases. The AI practices used these cases are mostly based on neural networks. The application of neural networks is mainly in vision and speech recognition. So human learns by building one skill on another, which AI is not capable of today and will remain incapable of at least for the next 50 years. One such example can be Google's DeepMind, a program that can learn one task after another using skills it acquires on the way. The AI treats three models, day, night, and snowy, of the same game differently. Alan Winefield at the Bristol Robotics Lab at the University of the West of England said, "I don't believe it brings us significant closer to AGI since this work does not, nor does it claims to show us how to generalize from one learned capability to another, something you and I haven't been able to effortlessly as a child." So within the next 50 years, we can expect to see information technology capable of the same type of flexible common sense reasoning that humans alone are capable of today. According to the estimates, the neural stimulation it would require processing power of order of 10 to the power 16, which would be available sometime between the year 2020 to 2025. But a brain simulation would have to capture the detailed cellular behavior of biological neurons presently only understood in the broadest of outlines. The overhead introduced by full modeling of the biological, chemical, and physical details of neural behavior, especially on a molecular scale, would require computational powers several orders of magnitude larger than Kurzweil's estimate. From the graph, which assume exponential growth of process power every year, the statistic behavior of single molecule can be replicated given processing power of the order 10 raised to power 45, which according to the estimates won't be around or sooner than the year 2065. The intricacy of scientific problems need to fully understand the human brains through psychology and neuropsychology have limited many researchers from emulating the function of the human brain into a computer hardware. Many research underestimate the solutions to these problems, because of which they make promises that are never achieved. Hence, it would be impossible for AI to achieve human level intelligence within the next 50 years, even if there is enough processing power in this world. So, the limitations on AI also plays an important role to stop AI from growing that fast. AI replacing humans 100% is really hard because artificial intelligence is limited only by the availability of data. It cannot operate on very small amount of evidence. Reliable sentiment analysis is needed, which is figuring out if a sentence is happy, sad, or sarcastic is really hard and which should be input by a human. AI also lacks creativity, and the cost and maintenance of AI system is very high, which is usually being done by humans. AI also lacks consciousness and it has computational limitations. People have developed products using artificial intelligence which they think are perfect, but like every other thing, there are some situations where AI cannot enact on its own. So this is a failure case with Tesla Autopilot. The enhanced autopilot capability of Tesla allowed it to match its speeds to the traffic conditions, keep the car within a lane, automatically change car lanes without requiring driver input, transition car from one freeway to another, exit the freeway, and self-park when near a parking spot. But in May 2016, a driver using a Tesla Autopilot was fatally wounded while driving on a Florida highway. Tesla said that neither the autopilot nor the driver noticed the white side of the tractor trailer against a bright lit sky, so the brake was not applied. So, who was wrong here? Was it the driver who was completely relying on Tesla's autopilot feature? Had the driver assumed that this technology had the common sense reasoning to react when an unexpected obstacle cut in front of the vehicle? In this case, the common sense reasoning to make the critical decision to brake was not present at the level of human reasoning. There will always be some level of errors in regarding to this. Now, there have been many other situations where artificial intelligence created by many big companies just couldn't handle the real world. Researchers at Facebook noticed that artificial intelligence they had created has started to make up their own code words. Initially, it looked like absolute gibberish, but it became clear that the machines named Bob and Alice were actually communicating with one another in a strange language only they understood. Another product by Microsoft was supposed to come off as a normal teenage girl. Microsoft's chatbot, an AI system called Tay AI, unexpectedly turned into a Hitler-loving, feminist-bashing troll. So what went wrong? In less than 24 hours after her arrival on Twitter, Tay gained more than 50,000 followers and produced nearly 100,000 tweets. The problem? She started mimicking her followers. Soon Tay began saying things like Hitler was right, I hate Jews, and I fucking hate feminists. But Tay's bad behavior, it's been noted, should come as no big surprise. The system is designed to learn from its user, so it will become a reflection of the behavior. One needs to explicitly teach a system about what is not appropriate, like we do with children. In another case, an artificial intelligence created by Google made headlines recently because of its ability to learn highly aggressive behavior. DeepMind, Google's cutting-edge AI company, has accomplished much thus far, including learning from its memory, mimicking human voices, writing music, and beating the best Go player in the world. Recently, the team behind the AI company ran a series of tests to see how it would respond to a certain social dilemmas, specifically if it would be more likely to cooperate or compete. Among the tests, one involved 40 million instances of playing the computer game Gathering, where DeepMind revealed just how far it would go to get what it wants. The game involved two scenarios: a wolf pack hunt requiring cooperation and a fruit gathering. The fruit gathering scenario proved particularly intriguing when the AI was given the ability to damage other intelligence by attacking them or shooting beams at them. The team discovered that the AI became more aggressive through attacking mechanism when less fruit was present. The more intelligent the AI network is, the quicker it is to get aggressive in competitive situations where such aggression will pay off. The behavior raises questions about the link between intelligence and aggression, what it means for an AI to mimic human-like emotions, responses, and if you are worried about potential robotic overlords, which we need to do to keep AI aggression in check. Another experiment is Watson with urban slangs. Let's see a video on this.
If there's one thing better than a smart computer, it's a smart-ass computer. Remember Watson, IBM's super smart thinking computer that utterly dominated at Jeopardy against the greatest players of all time? Well, would you believe at one point the computer sounded less like this?
Worst actress of the decade went to this celebutante for films including House of Wax and The Hottie and the Naughty.
What is Paris Hilton?
And more like this.
Rockabye baby on the treetop. Your mother's a whore, I ain't your pop.
See, it all happened back in 2011 when Eric Brown, the research scientist in charge of Watson, was tasked with the ultimate challenge of not only making a computer think, but be able to carry on a conversation with a human being. Only problem is, people tend to use a lot more slang in their day-to-day conversations. According to Brown, as humans, we don't realize just how ambiguous our communication is. So how did IBM solve this problem? By making Watson memorize all of UrbanDictionary.com. On paper, this was a great idea. Watson could learn everyday slang like hot mess or OMG, which in turn would easily enable him to have conversations with anyone, no matter what the vernacular. But then again, this is Urban Dictionary we're talking about here. And as anyone who spent 45 seconds on the site will tell you, it's the last place you want to send anyone to learn anything intelligent. Soon Watson was learning words like asshat, lady boner, front butt, and ugly cry. To make matters worse, Watson started reading Wikipedia and picked up even more bad habits, finally getting to the point where Watson answered a researcher's question by saying, bullshit. So what did IBM do? First, they washed out Watson's mouth with soap by developing a filter that would prevent it from swearing. Then they went the extra mile and completely wiped all of the data collected from Urban Dictionary. But hey, at least IBM learned how difficult it's going to be for future artificial intelligence to communicate naturally with humans, though it is a total bummer we'll never get to see Watson answer this on Jeopardy!
If Andy yearns for Brenda and Brenda cares about Charlene, who pines for Andy, the three of them form one of these. Kara.
What is it, threesome?
No.
So, do you think it's important for computers to learn human slang, or is it better that they speak the language properly?
So in the end, I would say that we should not expect such AI technologies in the next 50 years due to the following reasons. The cost of creating and running such powerful computers is very high and can't be easily justified when an inexpensive human workforce is available. Reoccurring AI winter mark incapability of progress, and interest in AI indicates that this may occur again. Challenge of understanding and simulating the extreme complexity of human brain. Mastering common sense reasoning. The exact factor that contribute to common sense reasoning for all types of situations must be determined. Countless trial and error must be used to figure how to program this correctly. This is a long, complex, and costly process. Growth of supercomputers. Computing power is increasing quickly, but it's not yet near that of a human brain. Even when computing power catches up with human brain, common sense reasoning will still be an issue. More powerful computing requires more complex rules and algorithms, and more complex and powerful computing power comes with a higher computing cost. So these are all the reasons why we shouldn't expect AI to be at par with humans even after 50 years.